So I'm Steve Day, British Car Ranch, and I want to thank you for taking time out of your weekend to sit in with us and check out this transmission overdrive tech session. Um, we appreciate the support very much, and I hope we're going to make a good effort to make it entertaining and informative. So as we travel around the country and present tech sessions to the car shows, the British car shows all over the country, it's a sure thing that the topic of a transmission overdrive is going to come up in the question section. They want to know, well, how do you shift it? How do you shift out of it? What kind of maintenance does it need? None at all, or what? What are some of the problems that show up? And what are some of the answers to those problems? We're going to cover all of that today in this session. So let's get right into it and talk about the theory of transmission and overdrive. And as we're going along, I may pause for a moment because I've got a question that comes in and we'll relay the question and then give you the answer. So the transmission's job is to transmit power from the engine through the drive line to the differential and out to the wheels. The engine creates the power and sends it down the line. If you push on your clutch pedal, it temporarily disengages the engine's power from the transmission and allows you to select the next gear without flashing. But for that to happen, the two gears have to be rotating at the same speed. If they're going at a different speed, you're going to hear about it. The job to make that happen is the clutch pushing in and reducing the power that's coming through, and also the synchronizer that's inside the transmission, which is a little brass thing for most of our cars. BJ8 has a steel one. They thought it was better. But the brass one, and that interfaces with a cone on the end of the shaft. And as it comes together, that brass grabs on a little bit to that steel and slows it down so that both gears are going the same speed, and then they can come together quietly. So this is a high wear item. It's intended to go so many miles and then need to be replaced because you've been shifting and using it. That's a normal pattern. Then you've got different size gears inside the transmission, and depending on which one you choose, it gives you a different RPM and a different power range. So 1, 2, 3, 4, it gradually gets faster and easier. So that's what's going on inside the transmission. Next, it gets to the overdrive. If your car's equipped with an overdrive, I assume it is because you're here today for that. And the overdrive is a multi-functioning piece. This unit right here is the overdrive from an Austin Healey. Looks very similar to some other model of cars. This overdrive over here is out of an MGB, but they operate very similarly. And that is, it starts with your button or your shift for overdrive, and that takes battery electric power and sends it down to the solenoid, which is mounted on or in the overdrive itself. And when that is activated, this is the solenoid here, clunk. And when electricity is applied to it, it changes electrical force into a mechanical motion, drawing this up. When that draws up, it transfers over to an arm that moves, and that arm is pivoting on a ball that's sealing off the hydraulic pressure. When that arm moves, the ball opens up, and you've got 400 pounds of hydraulic pressure coming out and heading for the operating pistons inside the overdrive. and the operating pistons turn it back from hydraulic back to mechanical motion and push the overdrive into overdrive gear. When you take the switch off, it releases the electrical and the mechanical and the arm and drains the oil out of the operating valves, causing them to come back under spring pressure, and you're out of overdrive. So there's an awful lot going on in there, going from electrical to mechanical to hydraulic and back to mechanical again. Then you've got an oil drain and back to a mechanical release. So there's obviously a lot of places for adjustments to go wrong and things to happen that eventually are going to happen, some wear and some adjustment problems. So the overdrive will give you 300, 400, 500 RPM drop in engine speed, which is exactly what it was designed to do. And it reduces the wear and tear and the sound noise as you're driving down the road on 50, 60, 70 miles an hour. Makes it much more pleasant and less wear and tear on all of the parts. So the additional thing in the overdrive system is a gear switch. This tiny little thing here is the gear switch. It'll come up here and give you just a little bit better look at it. There's not much to it. And this dome rides on the selector of the transmission and tells it when it's in third or fourth gear and allows electricity to pass on into the solenoid and creating the overdrive engagement. So this little baby right here, we'll talk about that under the problems, because if it's not adjusted correctly, the overdrive won't work. So that is the basic function very quickly. Now we'll talk about shifting. How do you get into overdrive, and then how do you get out? Going into overdrive, since it's electric, hydraulic, mechanical, you don't need to push the clutch in. The clutch doesn't do anything at all except slow down the gear change when you're shifting. So leave your foot off the clutch. Also, you can leave your foot on the gas at a steady pace while you're shifting into overdrive. Austin Healey goes in a nice upward motion. The Triumph and MG goes in now. Just a difference in the way that they do their accumulators inside the overdrive. So shifting in should be done between 2,000 and 3,000 RPMs. Now, you can shift it in at 1,500 or 3,500 or 5,000. It'll work. But the idea is you want to lessen the impact when it goes into overdrive and comes out, so that you make the whole system last longer. So 2,000 to 3,000 is ideal. The shifting out of overdrive should be done at 2,000 or below, once again, to reduce that impact for going in and out. And on the Triumph and MG, it will happen as soon as you flip that switch. Bam, it's out of overdrive. Plain and simple. The Austin Healey had a different idea, and they wanted to do it so that when you shift out of overdrive, you're always on the gas pedal a little bit. That is supposed to help ease the transition between overdrive and direct drive. So in practice, what has to happen is you're driving down in fourth gear and you're in overdrive and you see a stoplight or something you want to slow down for, or maybe a hill. You go ahead and flip, if you're in Austin Healey, go ahead and flip the switch nothing's going to happen until you push the gas pedal down 1/6 of its travel. That's a lot to remember. My mentor, Bill Bolton, had a wonderful description of it. And he said, think of it as the old Chevrolet automatic transmission shift down passing gear. Oh, okay. So when you're traveling in that car, you had to push down and you got a lower gear. That's exactly what's happening in the Austin Healey. You have to get pedal pressure to get it to disengage. Okay. If that's not confusing enough, try this on for size. You come up to a stop sign, you see a stop sign, you're in third overdrive. Okay. I begin to slow down. So I'm coasting. Flip the overdrive switch, nothing happens in my Austin Healey. I'm coming up closer and closer. I shift into second. My gear switch says, okay, out of overdrive. My switch is still off. My foot is off the gas, coasting to the stop sign. Out of overdrive, I think. Light turns green. I accelerate first to second. Great. Second to third. I've now shifted from third to third overdrive automatically because it's still engaged. Confusing. It's not engaged because of the gear switch. When the gear switch says go, it will go ahead and engage if you haven't depressed the accelerator yet. So, recap. Think of it as the automatic transmission kicked down. That's probably the easiest way. Did I lose you yet, or you got a question? Okay. On we go then. The little gear switch is meant to protect the reverse gear in the car. You do not want overdrive to be accidentally engaged while you put it in reverse and try to back up. Now you're going in the other direction with the drivetrain, and if it happens to be stuck in overdrive, it'll break the shaft inside. So they put this in to make sure that it cut it out with no questions asked as soon as you got below the 3/4. I know Triumph will, or MG will let you go in 2, 3, 4, but you get the idea. So if you ever have been in your car, put it in reverse, and just started to back up gently and felt a resistance like you were going over a rock or a piece of wood, if you have just previously been in overdrive and you put it in reverse and feel that, don't force it. You're only going to be able to go forward until that releases inside the overdrive. The one time I have seen that was when the clutch for the overdrive, not your foot clutch, but the overdrive clutch, which is inside here and actually says direct drive, overdrive. It got stuck friction-wise in overdrive. It wouldn't come out no matter what I did. Okay. That's when you take, that fuel pump hammer that you've got? You take that and you tap on this section here and it jars it loose and it comes out overdrive. Okay, now you can motor on. You do need to get that checked out and find out why and be aware that it is a small possibility. So let's talk about maintenance if we don't have any questions that are concerning so far. Okay. Maintenance. What kind of maintenance does that transmission overdrive combination and differential? We'll include the differential for purpose today. What kind of maintenance do they need? They need clean. Let me show you one of the orifices in the overdrive. I'm not sure that you could even see it, but there's a tiny hole right here, that's this big. Now, that's like a human hair. What do you think sludge and grease and carbon and whatever is going to do circulating in the oil system? It's going to plug that hole, and that's going to keep the overdrive from coming out. This is the operating valve. And when it goes up and down like this, it's controlling the oil flow to the overdrive, and it requires that hole to be clean to allow the pressure to drop off back into the oil pan and come out of overdrive. If that gets a tiny piece of schmutz in there, it's not going to drain and it's not going to come out of overdrive, or it's going to be very slow. So clean is important. If you were to look at the transmission, it's got similar but slightly bigger oil holes. Here, here, they're all over the place. So dirt and crap can get in there. Reduce the oiling capacity for those gears, burn them out eventually, cause wear. And those size of orifices are all over the place in the transmission and overdrive. So it makes sense that we keep that oil fresh and clean and drain off any of the impurities. So the reason it gets a little dirty is because in this transmission, it has an oil sump, and the overdrive has an oil sump, but they're the same one. So you're drawing oil for both units from the same pan. The transmission has steel and brass and other things moving around in here so that you have filings and metal particles and stuff going on that are getting back into the overdrive. And that doesn't make any sense if you've got something this size that needs to be clean. It really needs to keep itself clean. What we are seeing is overwhelming lack of maintenance on the overdrive transmissions. And when we finally get them apart and look at them, they're full of sludge and junk. They have not had oil changes on a regular basis. So if you don't know when the last time your transmission oil was changed, change it now. Start fresh, and then it may take you this year and next year to change it again and get it all cleaned out, but you need to start from a clean place and get that oil taken care of. Once you've done that, once you have it clean, now we can go to a maintenance interval of 5 years or 10,000 miles. Some of us drive 700 miles a year. Some of us drive 6,000 miles a year. So whichever one comes first for you, change your oil in your transmission and your overdrive. And the same thing goes for the differential. In very rough terms, the differential is operating the same kind of gearing and requirements as the transmission overdrive. So it needs to be taken care of too. You folks with the TR6s, unfortunately, they saved 12 cents per car and didn't put a drain plug in the differential. When we get a TR6 come in and we're doing a service on it, we put in a drain hole. There's a fill hole, but there's no drain. I guess they thought it would last forever. So the next thing that happens on maintenance is paying attention to the noise level on the transmission and the overdrive. And these units are 40, 50, and 60 years old. And they were designed even earlier than that. So it's, you might even call it antique engineering. Not as efficient or as quiet as modern cars are today. One of the things we have trouble with is making sure that our customers aren't applying their Lexus standard to their Healey Triumph MG, because the two of them are completely different vehicles. There is going to be a level of noise from the transmission and the differential and the overdrive. That's just part of the charm of the car. But if you were to notice a new noise, something that came up that you hadn't noticed before, okay, that's the time you want to get it looked at and figure out what's going on. Oh no, we're all friends here, aren't we? If we talk about oil, we're going to have battle lines drawn in all directions. The most controversial topic in the entire world is what oil you should use in the engine and in the transmission and overdrive even more, and the differential. Now, I'm not here to force you to do anything. I'm here to give you the very best answer to that question, and then you get to decide what you're going to do with it. The 1955 manual for the Austin Healey or any of the other brands say you can use 30 weight, you can use Dawn detergent, you can use engine oil. They're kind of all over the place, aren't they? So how does that make any sense in a transmission that has gears? They're using an engine oil in a gear-driven vehicle. Well, that's what they said. Well, I have written an article on explaining the difference and how that came about, and it will be on the website Wednesday in the tech session for you to go in and read it. So you can either take my word for it now, or you can look for the proof in that article later. We're not going to go into it that deep today. Suffice it to say, we have done extensive research, even talking to the Normanville de Lecoq engineer that did the lubrication specifications, and found out exactly what that unit needs for lubrication. And what it turns out to be, the article will give you all the details. What it turns out to be is gear oil, 90 weight, EP, the extreme pressure additives. And that's the oil that is supposed to be, should be used in the transmission overdrive. Same thing for the differential. There's a slight difference because there's brass in the transmission overdrive. We've seen that here. And the bushings and some of the shims. And GL4 is a API rating. GL4 gear oil is the one that is used in the transmission with brass. GL4 is now almost extinct because there's not that many of us buying it. You're supposed to be changing your oil more, but now it's running away. We have found a source, and it's, thank you, Christopher. It is exactly what we need for the transmission overdrive to be 100% accurate. Now remember, you can use 30 weight, you can use engine oil, you can use whatever you want. And the reason that you will get away with it is because we do not pressure the transmission overdrive to the point where it will fail. We don't go up a 6% grade every day. We don't tow. We don't operate in 115-degree temperature. So we're not stressing the engine oil, the 30 weight, to the point of failure. It's not doing the same job, not protecting it as well. But because we're only driving 1,000 miles a year, it's going to take 10, 15, 20 years for that wear to finally kick in. But it will. But that's your choice. You've asked me what the right oil is. That's the 90 weight gear oil. GL4. GL5 is the new modern oil, and it has too much phosphorus in it, and it eats up the brass. Okay, can't do that. So if you wanted to, you could use a GL5 in the differential, but not in the transmission. We just use the GL4 in both because it gives the perfect protection. Okay. And that's our recommendation. Okay, how about problems that we see often with the transmission overdrive? Well, there's probably been a lot of jokes made about the leaking capability of a British sports car, but it's true. That's the level of engineering and expertise that we had back in those days, and that's what it is. Oil can get out of the MG Austin Healey Triumph and get on the ground. Some say that was the way that they engineered in to know that you still had oil left in that device. Well, okay. The first approach to solving that, try to use a ladder stair-step approach. What's the easiest, least expensive solution first? And then work up to whatever the customer is willing to spend from that point. And that would be what we call a surface seal. We thoroughly clean the unit or the joint that's leaking. Toothbrush, wax and grease remover, make sure it's really nice and clean. Then we'll use, thank you, Christopher. Well, Permatex Right Stuff. And that is, it can come in tubes or it could come in caulking guns like Christopher has in his hand right now. And we smear some on there and then we finger seal it and make a nice smooth barrier on the outside of where the leak is happening. That slows it down. Sometimes it even cures it. Then past that, you pull the device, whether it's engine, transmission, differential, overdrive, and take it apart and reseal it. And when we do that, we pull the studs, we flat file the metal gasket surfaces, because over the years, to solve the leaking problem, hatchet mechanics have tightened it too far. It pulls that stud and draws metal up right in the gasket sealing surface. And now you've got a gap. Hard to seal. Okay, flat file that, get back to perfect, and then use the proper gaskets and gasketing material. So we get to the overdrive problems, and 90% of the problems with an overdrive are solvable outside of the case itself. You don't have to take it out of the car. And that is, okay, cleanliness is number one. You've got junk blocking the passages. Oil can't get in and do its job and can't release. So flushing with oil, changing it, getting it back to being clean again is the first step. The next step after that would be, okay, your overdrive will not engage. I'm pushing the button and nothing's happening. So check your oil. You got to have enough oil in it for it to work. Check your electrical side. We'll go into that on another tech session. Check your hydraulic side for pressure. Check your adjustments. That's usually where the problem starts to show up is there's places all over the transmission and inside in that need adjustment. And naturally, they get out of adjustment. That's when they either don't go in, or they don't come out, or they drop out. All three of those could be the same kinds of problems that show up. So, adjustment, check your oil, check your adjustments, and if the dropout, if you're going along in overdrive and all of a sudden it just drops out on you without you doing anything, remember the gear switch? The gear switch has an adjustment to it, and it's a very complicated adjustment. It's a gasket of different thicknesses that goes in here, and when you screw it down, it adjusts the tension on that ball and allows that switch to say yes and no. If you develop a problem where it won't go in, or it won't come out, or it drops out by itself, take your gear shift and go in the neutral slot, go left and right. What that's doing is activating or deactivating this gear switch. And if you're driving down the highway and it won't come out of overdrive, and you've got your foot at 1/6 on an Austin Healey, take your gear shift and just push it while it's in gear, one way or the other, and see if that makes the overdrive come in or out, depending on what the problem is. If this is on the borderline of needing adjusting, it will give you that kind of a fault. So, by and large, that's the problems that we hear over and over again and see is, and frankly, number one is the adjustment of the arm. Remember when we went from electricity to mechanical? The adjustment of that mechanical arm is really critical. And sometimes the slightest amount will be either it won't go in or it won't come out. Unfortunately, you have to take the transmission tunnel off to get to it most of the time, but it's better than pulling the overdrive. One of the other problems is jumping out of gear on the transmission. Let's say you're coming down a hill and you're starting to let off the gas a little bit. Pop! It pops out of gear. That can be a factor of the synchro being worn out. It can be a factor of the gear face is not hanging onto the gear properly, and that little bit of back torque pops it out of gear. It's an internal repair at that point. So we do our favorite term. We educate the driver to drive around it, and you live with it until you can't stand it anymore. Then you have it fixed. So it's not something that's catastrophic, but it sure is annoying. So after all of that's gone on and you've made it through and you've done your oil change, you've done your adjustments, and it's still not working right. And you bring it to us and we put a test gauge on the oil pressure system, and sorry, it's only got 250 pounds of oil instead of 400. It's internally worn out and needs to be rebuilt. That's when we pull the engine and transmission, or pull just the transmission, depending on which car it is. Get it out, take it apart, assess what's going on, talk with the customer, give him an estimate of cost, what we're looking at, and then rebuild it from there. Some of the functions that we have to do are the bearing surfaces on the transmission and the overdrive. For instance, the tip here get excessive wear. You can almost feel it on this one. And it needs to be rebuilt. We found a machine shop that will turn this down and put a bushing, weld a bushing on there and go back to a brand new bearing surface for that. If it's worn too badly, and perhaps you can see the black here, the shaft has wear everywhere on this one. This is a bad one. And you have to buy a new main shaft. Fortunately, some of those are available. Unfortunately, some of them are not. And if the gears have the same kind of problem on the bearing surfaces, the bearings, 2, 3, and 4, fourth gear bearings are very hard to get or not available at all. So we're forced into the decision of, okay, mine are really bad. I've got to go find some used ones that are better than mine, but they're not perfect, and put it together, have a transmission that works fine, very serviceable, but it's making a little more noise than it was before because of those new gear, not new, but used gears that have wear on them themselves. So it's a real throw the dice thing, rebuilding it with used parts and new parts. It's all up to the customer and what he wants to do. If he's willing to compromise and drive around it, we're in business. If not, then we go to the third option, and that's the 5-speed conversions, which are available, Austin Healey, MG, Bryant. Expensive, yes, but it's a really nice solution. It gives you wonderful gear changes. For the Austin Healey, now you gain a first gear synchro, so you can get into first gear. The shifting is much better. The whole design of that transmission, the 5-speed transmission, is just a modern wonder. Makes a great option.